Here we go with 3.05. So we're going to use polynomial division to simplify rational expressions and reason about excluded values. So don't get too worried. I know that polynomial division is something that seems daunting, but I promise you the second time around it'll be a little easier, and you'll start to realize the many uses of it, because in looking at rational expressions, they are simply a quotient of two polynomials, and so it's natural to think that we can simplify by dividing. So let's take a look at it. So let's go start off just by dividing 10 by 3, or simplifying the rational expression 10 over 3. Go ahead and do that on your own. Shouldn't have been too hard, right? When I do 10 divided by 3, I think about the fact that 3 goes into 10 3 times. But there's a remainder. There's a remainder of 1. So how do I put that into my quotient? Remember, this quotient here is what I can multiply 3 by to get 10 back. Okay? So let's just think about this real quick. Okay? I'm going to take 3, it's my divisor, and I want to multiply it by my quotient, which right now is 3. I want to multiply it by 3. And what I need to get is I need to get back 10. So think about it. Well, when I multiply 3 by 3, I'm going to get 9, right? My remainder, of course, is 1. So what else can I multiply 3 by, so that I get that 1 left over, so that I end up with 10? And the reason we write 3 and 1/3 is because what we need to multiply by is 1/3. That's what we call it, 3 and 1/3. It's the same as saying 3 plus 1/3. Because now when I multiply 3 times 3, I'll get 9. And when I multiply 3 by 1/3, I'll get 1. And so I'll have 9 plus 1, which is in fact 10. Okay, so the way that this works, right, is we have the main part of our quotient, which is the 3, and then our remainder is, we take the remainder and we divide it by the divisor. Okay, so that's how division works. And now what we're going to do is we're going to try simplifying this rational expression using the same method. Okay, so I want you to try this on your own. Go ahead and split your paper in two and try this first. Go back and look at some previous notes, but I really want you to give you at least 2 minutes of reworking it, and then maybe a couple more minutes of actually dividing to see what you can do. Alright, so we have a rational expression where we're taking this quartic polynomial and dividing it by this linear term here. And so I want to simplify, and to simplify I'm going to need to do polynomial long division. So I want to actually do this somewhere else. I don't want to do this right here, because this is essentially scratch work that I'm doing. Okay, so we'll take it over here, and I have x to the 4th plus x plus 1, and I want to divide it by x plus 1. Okay, so let's first just think about what I'm looking to get back. Okay, what type of polynomial, remember what my answer here, what type of polynomial can I multiply by x plus 1 to get x to the 4th plus x plus 1? And so the leading term, of course, is going to be x to the 3rd, right? Because x to the 3rd times x to the 4th, or times x to the 1st, will give me x to the 4th. So that's what I'm going to start off with. X to the 3rd, and then I multiply that if this were the first term, so I'm going to actually write this here, x to the 3rd, right? If I were to multiply x plus 1 times x to the 3rd, I'm going to get x to the 4th plus x to the 3rd. Okay. And now I want to subtract away everything that I get. Okay. And so I'll distribute in this negative, so this will become negative x to the 4th, negative x to the 3rd. Okay? So x to the 4th minus x to the 4th, those will cancel. And now notice that I don't have any x to the 3rd powers here. So I have 0 x to the 3rd minus x to the third, which is a negative x to the third power. And then I'll drop down this x and this 1, so I have negative x to the third plus x plus 1, right? So now what I have remaining is this piece here, right? I got a positive x to the third from this multiplication. So from the next multiplication, I'll need to get a negative x to the third to counteract it, because notice I don't have any x to the third powers here. So what will that be? Well, what times x will be negative x to the third? It'll be negative x squared. And multiply, I will get a negative x to the third minus an x squared. And now I can subtract again. I will distribute through with my negative sign. This will become positive, and this will become positive. All right? And so I have negative x to the third plus x to the third. These will cancel. Notice there's no x squared up here. So it'll be 0x squared plus x squared, which is just going to be an x squared term, plus an x term, plus 1. Alright, so I go through, and once again, I need to know what times x, what do I have to multiply x by to get x squared, and of course, that's just a positive x. Okay. Alright, so I multiply by positive x. I'm going to get x times x, which is, of course, x squared. X times 1 is going to be a positive x. So now I subtract everything here. Negative sign distributes in. And now I have x squared minus x squared, which cancels. X minus x, that is also 0. And so I'm left with 1. Okay. Now at this point, what you're going to realize is, of course, how many times does x plus 1 go into 1? Well, it goes in 0 times, right? There is nothing that I can multiply x plus 1 by to get 1. And so I have a remainder of 1. Okay, so let's think about how this simplification will look. X to the third minus x squared plus x with a remainder of 1. Okay, so think back to this example up here, right? I had a remainder of 1 as well. The way I wrote my quotient was the number of times that 3 went into 10, the number of times x plus 1 goes into x to the fourth plus x plus 1 is this polynomial here, and then I add on the remainder over the divisor, right? Because I will need, and I'll show you why this works in a second. So we're going to add on the remainder 1 divided by the divisor, which is x plus 1. Okay? And let's just think about, why does that work? Imagine if you were to take this polynomial here and multiply it by x plus 1. So if I were to go through and multiply, when I multiply x plus 1 by this part here, I'm going to get almost everything that I need for my x to the fourth polynomial with a remainder of 1. But when I multiply x plus 1 by this last piece, the x plus 1s will cancel, and so I'll be left with 1, which is exactly what I will need. Okay? So this is the simplification here, and let's just think about it. What value will this not work for? What is the excluded value going to be for this expression here? Well, notice that the only thing that will make this undefined is if this quotient here is undefined, and that will occur when x is negative 1, just the same as this previous expression. So this is when x is not equal to negative 1. Alright, and now I want to talk about, why did we do this? Why was this the easiest way to simplify? And remember, we've simplified by factoring previously, but here we couldn't factor x to the fourth plus x plus 1. Didn't work, and so the easiest way for us to simplify it is just to divide. Remember also that x plus 1 will only go into this x to the fourth plus x plus 1 evenly if it were a factor, right? If negative 1 were a root. And so when I get a remainder, I then know, of course, that I can't factor this in a way with x plus 1. Okay, so what we want to just really internalize is that if I can't factor the numerator of my rational expression, then I can still simplify by doing long division. Okay, so if I can factor, I factor. If I can't, I can simplify by doing long division. Problems for you. Here's the first one. I'm going to show you the second one in just a second. So go ahead and try this one and then press play and we'll take a look at the next one. Alright, hopefully that went well. Make sure that you think about this question and answer it in the best way you can. Okay, I know that the polynomial division seems laborious, but make sure that you give it a try and go for it. Next, go ahead and try this one here, and make sure to think about the excluded values where it is undefined. And we will take a look at both of these questions on Monday.